Okay, so if we talk about this chapter, logarithm, this is one of the most easiest chapter and a very scoring topic. We have certain laws of logarithm, properties of logarithm, based on which questions are normally asked. Yes, there are some typical questions which are possible, like series questions can be there, series based on logarithm. Then there can be, let's say, expansions, which is based on logarithm. Taylor's expansion is there, by which you can expand any logarithmic series. Any function I'm saying, log 1 plus x like this, you can expand that basically. But the thing is, over here, in this topic, in this chapter, we will mostly focus on the properties of logarithm. Properties of logarithm and questions based on those properties. Okay, previous year questions as well, so we are going to see. It's a very small chapter and a very scoring one. Okay, normally questions are given in the exam just for you to just score. You score good marks so that with the help of this particular chapter, you score good marks in your exam. So we have this particular chapter as logarithm. So we'll start with the definition, then we'll move on to the properties, and then we'll see the questions based on that. Yes, it may happen that a lot of inequalities can be there. I told you series questions can be there, inequalities can be there. Right. So one by one, we are going to cover that. Inequality part, we are going to cover in inequality. If there are any specific kind of inequality, then we are going to either discuss in problem solving sessions or in inequality section. But let us first see what are the problems based on this particular thing, only the properties or the laws of logarithms. Okay. So first we start with the definition of logarithm. What exactly is this logarithm? And why we use logarithm, log, or basically, in short, we call this as log, basically. We use logarithm to simplify a particular equation or any representation, any power representation which cannot be easily simplified can be solved by taking log on both sides. So logarithm is basically a tool in order to simplify a particular equation or representation, whatever you can call this. So basic definition says that if a positive real number other than 1 and x is a rational number such that a to the power x is equals to n, then we say that the logarithm of n to the base a is x. Okay, or we say this, x is the logarithm of n to the base a. We write it in this format, that this is x is equals to log n base a. Log n base a. Okay, which means over here from here we can say that a to the power x is equals to n if and only if log n base a is equals to x. Okay, this is the representation. First of all, understand this representation. Don't get confused over here. I have seen students getting confusing with this particular representation. What is the meaning of this thing? First of all, this representation in terms of base and powers, basically concept of base and powers. Suppose you consider a number, suppose just a random square, suppose a perfect square number, suppose 36. Okay, 36, 6 square is 36. So a perfect square number I'm considering. Right over here, this particular 36 can be written in either in the exponential format or in the logarithmic format. Any number can be either written in terms of exponential format, in terms of exponents, or in terms of logarithm, which means either you write this as 6 square. Okay, what is 6 square? 6 square is basically this particular square, my whole square means whole to the power 2. This is the power, or some can call this as the degree or the exponent. And this particular 6 is known as the base. This particular 6 is known as the base. And suppose now you want to transfer this particular 6 square in terms of logarithm, and you want to write this in terms of logarithm, then what you will write? This 6 square, 36 is equals to 6 square, which means log 36 base 6 is equals to 2. Okay. The 36 is what degree of 6 basically? 6 এর কত power দিলে 36 হবে. That is log of 36 base 6, which is 2. 36 is what degree of 6 basically? 6 square. So 36 log 36 base 6, because this is your base, so this will come to the base. So 36 base 6 log 36 base 6 is 2 basically. This is the logarithmic representation, in which this particular thing is now your exponent. This is your exponent or the power or the degree. This is the logarithmic representation. Okay. Basic logarithmic representation of a number. Okay. Any number you take, any numbers, you take any number can be represented in two forms. Either you represent this in the exponential format, which means a to the power x is equals to n, or you represent the same thing in terms of log. So what you will write in general, log n base a is equals to x, one is the power. Okay, this is the logarithmic representation. This is log and this is anti-log. This is anti-log. This is log and this is log-er ulto, which is anti-log. Opposite of log, that is anti-log. Okay, so either you write this in this format, which is a to the power x is equals to n, or you write it in this format, which is log n base a is equals to x. So these are the two formats, and we write this in log. Log is basically the short form of logarithm. Okay, abbreviation of the word logarithm. Okay, clear with this? Very basic definition I have just explained. A lot of properties are there from which questions are normally asked. Now here I'll deal with the questions based on properties of log. I'll not deal with the questions based on logarithmic functions, because we have done the log function in the chapter of functions, domain and range of this thing. Just a brief idea I'll just give about this log function. Okay, just a brief idea. Not in detail we are going to do, only properties based questions we are going to cover in this chapter. Okay, so I hope this thing is clear, that what exactly is this log and anti-log. Opposite of log is basically anti-log. So any number can be either represented in the form of powers or in terms of log, either in terms of anti-log or log. Okay, like suppose you consider this example. Let's say one more example. You have 10 square. Suppose over here I'll just write it down. So you have 10 square. 10 square is what? 100. Okay. So you want to write the same in terms of log. This is the anti-log. So you want to write this in terms of log. So whatever is the base will come down to the base of the log. Log 100 base 10 is equals to the power, which is 2. This is the value of log 100 base 10 is equals to 2. Similarly, suppose let's take one more example. Suppose you want to consider 10 cube. Suppose 10 cube is 1000. 10 cube is 1000. Log 1000, you write it in this format, log 1000 base 10 is equals to 3. This is the value of log 1000 base 10, which is equals to 3. Okay. Clear with this basic idea about log? All of you might know this thing because you have somewhere you have done log in your junior classes as well. Most probably in 9th or 10th, you might have faced this chapter. But in detail questions we are going to do in this particular chapter in 11th standard. There are various standard questions based on log. So in order to solve those standard questions, you need to be very clear about the properties, you need to have a clear-cut idea about the properties, right? So all of these properties we are going to discuss next. Clear? I hope this thing is clear. This is the representation of log and anti-log. And log is basically a function, right? Log x is, whenever we define this in terms of function, fx is equals to log x. Log is basically a function, but in this particular topic, we are going to use log in terms of tool, basically, in terms of a tool. We'll see log as a tool which will help you to simplify certain questions, right? Which will use to simplify certain things. So function is different. Function is basically a function. We deal with that function. Okay, log x is basically a function. In the chapter of functions, we have discussed what is this domain, range, and all these things, graphs of log functions and all we have discussed over there long time back. Okay, just a brief idea. Once again, we are going to just recall that thing, but not in detail. And one more thing, I have told you this thing, log function. What are the domain and range of log function? If you just remember, there are various domains and range, right? Obviously, domain is defined for this particular x greater than 0. If you have the fx is log x base a, x is greater than 0, and for various values of a, the graphs of log function differs basically. But the range is always real number. Domain of log function is all positive real numbers, right? When the values of x basically. Domain of x is always all positive real numbers. Okay. But the range is all real numbers. Range of log function is all real numbers, right? Right, starting from negative to positive. So suppose with the help of this thing only, let's see some examples. Suppose if I consider one more example. Suppose if I consider, let's say 3 to the power 4. 3 to the power 4 is equals to 81. Right. So what we'll write in terms of log? This is log base will be 3. Log base 3. Over here you will have 81 is equals to 4. This is the logarithmic representation. If suppose if I say you have 7 to the power 0 is equals to 1. 7 to the power 0 is equals to 1. Okay. So this means log 1 base 7 is equals to 0. Log 1 base 7 is equals to 0. Similarly, if you consider one more example, this is a very nice example. 81 raised to the power 1 by 4 is equals to 3. Okay, 81 raised to the power 1 by 4 is equals to 3. Clear? 81 is what? 3 raised to the power 4. So that's same as 3 raised to the power 4 into 1 by 4. That is basically when in the powers I'm saying. So you have 3. So 81 raised to the power 1 by 4 is 3. This means this particular log 81, so log 3 base 81 is equals to 1 by 4. This is also one nice example. Okay. Clear? So this is what we have derived from the definition. What else we can say? What else we can say? You see, in fact, this is a property which we'll just learn next basically. From the definitions above, you can see, you can observe log. Suppose if I say that, suppose like this, if I say, let me explain in this manner. You have any numbers, let's say any positive real number, let's say a. Any positive real number you have, let's say a raised to the power 1 is equals to a raised to the power 1 is equals to a. Obviously, a to the power 1 will be what? A only. in terms of log, if you write this, which means log of a base a, this is your base, okay, and this is the log part, log of a base a is equals to 1. We have this result, log a base a is equals to 1. You can remember this as a result, which we are going to see next also. Okay. So log a base a is equals to 1. Okay. So this means also, if you just see some of the more examples, let's say that the logarithm of the number to the given positive real number, as base as the index or the power to which the base must be raised in order to make it equal to the given number. What is the meaning of this thing? Let's see. Let's see with the help of an example. Let's say log 64. Log 64 base 2. Log 64 base 2 is what? What is log 64 base 2? You have to find the value of this thing. So log 64 base 2 is basically any real number. Let's say log 64 base 2 is equals to x. Then x is what? X is any real number. This is any real number such that now we are going to see ulto case, 2 to the power x. Anti-log we are going to see, 2 to the power x is equals to 64. Isn't it? Log 64 base 2 is equals to x, where x is any real number such that 2 to the power x is equals to 64. What is the meaning of this thing? 2 to the power x is equals to 64. What are the values of x? X is equals to 6. X is equals to 6 from here. Okay. Similarly, suppose if I take one more example, log 625 base 5, suppose. What is log 625 base 5? You are asked to find out the value of this thing. So log 625 base 5 is basically x, where x is any real number such that 5 to the power x is equals to 625. Again, same logic. 5 to the power x is equals to 625, which is x is what? X is equals to 4 in that case. Right? X is equals to 4 in that case. Again, suppose log, you consider this thing log, let's say log 3 base 9. What is log 3 base 9 if you are asked to find out? So log 3 base 9 is basically x such that you have 9 to the power x is equals to 3. 9 to the power x is equals to 3, which means, now tell me what is x? 9 to the power x is equals to 3. What is x in from here? What is x? 9 is basically 3 square. 3 to the power 2x is equals to 1. X is equals to half. So log 3 base 9 is equals to half. Right? Similarly, you tell me what is the value of this thing? What is the value of this thing? Log 0.01 base 10. Tell me what is the value of this thing? Log 0.01 base 10. Follow. What is the value of this thing? (0.01 base 10). Ekdom. Log 0.01 base 10 is -2. Why -2? Let us understand this. Let's see this. So we have log 0.01 base 10. So this means what? If you use the basic definition, this means if this is equals to x, then this is what x? This is x such that 10 to the power x is equals to 0.01. 10 to the power x is equals to 0.01. Now 0.01 means what? If you write 0.01, this thing is what? 1 upon what? 100. 1 upon 100, isn't it? This thing is what? 0.01 is what? 1 upon 100. Right? Now 1 upon 100 can be written as 1 upon 10 square, isn't it? 1 upon 10 square. Okay. Or you can just simply, not whole square, just write this as 1 upon 10 square only. 1 upon 10 square. Okay. So this is same as 10 to the power x is equals to 10 to the power minus 2. So this is x is equals to minus 2. Okay. Now suppose if you are asked to find out what is, I'll do it over here itself, what is log 0. Let's say what is log 1000. Suppose you are asked to find out what is log 1000 to the base 0.01 to the base 0.01. How will you find out log 1000 to the base 0.01? Maybe with the help of properties, this will be more easier. So it's better we start with the properties, then we'll see what exactly is this log 1000 to the base 0.01. Because log 1000 to the base 0.01 is equals to x. X is a real number such that you have 0.01 raised to the power x is equals to 1000. Maybe you can directly also find it from here itself, and obviously answer will be negative over here. How will you find this? This is 0.01 raised to the power x over here. So we have 0.01. Convert this 1 to the power 100 raised to the power x is equals to 1000. 1 to the power 100, which means 1 upon 10 square, right? 1 upon 10 square, mane this is 10 to the power minus 2x is equals to 1000. Mane this is 10 cube, right? So this means minus 2x is equals to 3. X is equals to minus 3/2. Either you go by this manner, or I'll teach you one property which will use them to solve this thing. It's the same, logic will be the same, but the thing is, it is better to also understand the property and solve this thing. Let's move on to the properties of logarithm. Properties of logarithm. So one by one we are going to do all the properties. First of all, you need to understand one thing before we start with the properties, that when do log exist? First of all, log x base a, whenever we say log x base a, when log x base a exist? When does log x base a exist? Log x base a, the conditions you can write down somewhere over here. The necessary condition for log x base a to exist are what? There are three conditions. First, x should be greater than 0. Obviously, for domain to be defined, x should be greater than 0. Second is a should be also greater than 0. Base should be also greater than 0. And third one, a is not equals to 1. A is not equals to 1. You will never find the base to be negative, x to be negative, and a not equals to 1. Because if you go with this particular logic, that suppose if a is equals to 1, if a is equals to 1, then you will have log x base 1 is equals to, let's say something k. Okay, log x base 1 is equals to k, suppose, right? What is the meaning of this thing? 1 to the power k is equals to x. That's the meaning of this thing. 1 to the power k is equals to x. Right? If k is infinite, that is different. That is indeterminate form. If k is infinite. But if k is any finite or any finite value, suppose if you take this 1 to the power n, 1 to the power k, 1 to the power 2, 1 to the power 3, any finite value, if you just give this is always 1. Money x is equals to always 1, isn't it? X is equals to always 1. You will get the value of x to be 1. So suppose if, which means log value is always 1, and if log is any number, like suppose x is some different number, then this will always be remain to be 1, which is not allowed in this case. A is not equals to 1. Okay, concept is this way, that this is always 1. Obviously, any domain for which you give, this cannot be always 1. So base is never accepted as 1. Base value is never 1. Base value is never 1. Either x is greater than 0, a is greater than 0, a not equals to 1. These are the three conditions for the log to exist. The necessary conditions. Further, there are various cases. What happens when a lies between 0 to 1? What happens when a is greater than 1? Okay. So various cases are there for which we have different graphs. Right. Various cases are there for which we have different graphs. You know, when a is greater than 1, then log x is an increasing function. The graph of log x will be in such a manner that the graph will be an increasing function graph. The graph will increase. And if a lies between 0 to 1, if a is a proper fraction, then the graph will be decreasing. Then log function will be decreasing. We have discussed this under function chapter, which is the concept of domain range. In there we have discussed this thing when we were discussing graphs and all, where there we have discussed this thing. So suppose if I come down to the properties of log, okay, properties and the laws, mainly not the properties, we in standard language we call this as the laws of logarithm. The laws of logarithm. What are the laws we are going to see next? Okay, first property, or the first log, the first law, the first property. Log 1 base a, log 1 base a is equals to 0. Log 1 base a is always equals to 0, where a is not equals to 1, obviously, and obviously a should be greater than 0. Okay. How do we prove this? I think you have seen the proof. How do you prove this? Log 1 base a, suppose log 1 base a is equals to k, suppose any number k if I take. Log 1 base a is equals to k. This means k to the power, sorry, a to the power k is equals to 1. And when this is valid, when this is equals to 1, when k is equals to 0. When k is equals to 0. And so you got the value of k. So log 1 base a is equals to 0. Important property. Directly you see log 1 is 0. To the base a, 0. Okay. Next we have second property. What is the second property? Property number 2. Log a base a is equals to 1, where a not equals to 1 and a greater than 0. Log a base a is equals to 1. Just now you have seen. Just now you have seen. Again, proof of this thing, quite easy. Logic will be the same. You have log a base a is equals to 1. Okay, we have to prove this. Suppose if I take log a base a to be k, suppose, such that this thing will be a to the power k will be equals to a. Isn't it? A to the power k, base raised to the power k is equals to the power, the power mainly. I have told you this thing in reverse manner. In reverse manner, you have a to the power x is equals to n this way. In reverse manner, if you see a to the power x is equals to n, this implies log n base a is equals to x. Or in reverse also, log n base a is equals to x, mane a to the power x is equals to n. A is base, x is power, exponent, n is the number, mane log of this thing, component of this log. A to the power k. So by this logic, we have log a base a is equals to k, means a to the power k is equals to a. Okay. Clear? Base to the power k is equals to component of log, this thing, mane power basically. Right? Okay. A to the power k is equals to a. So what we do from here? When this is true, obviously this is true for k is equals to 1. Obviously this is true for what? K is equals to 1. Power is 1, then only a to the power k is equals to a. So log a base a is equals to 1. Okay. These are two basic properties. So log 1 base a is equals to 0 and log a base a is equals to 1. Okay. Third property. What is the third property? Third property is also known as the product rule. Also known as the product rule. What is the product rule saying? Let us understand this. What is the product rule? Product rule says log, let's say log log x1 log x1 plus log x2 to the base a for each. Log x1 base a plus log x2 base a is equals to log x1 into x2 base a. Obviously, same thing, a will be greater than 0, a not equals to 1. And what is x1, x2? x1, x2 are positive rational numbers. Positive rational numbers. x1 and x2 are x1, x2 are positive rational numbers. Okay. So log x1 base a plus log x2 base a is equals to log x1 into x2 base a. Okay. This is known as the product rule. This is known as the product rule. How will you prove this? Quite easy. Log x1 base a and we have log x2 base a. So individually take this. First we have log x1 base a, right? First we have log x1 base a. So suppose x1 base a, log x1 base a is equals to suppose k1. Okay. And consider log x2 base a is equals to k2. So from the first one, what you will get from the first one, log x1 base a is equals to k1. What you will get? Log x1 base a is equals to k1. Use the property a to the power k1, because this is what? This is the power. So this will go to the power. Base to the power k1 is equals to x1. Similarly, base to the power k2 is equals to x2. Right? Clear with this? Then what we do? Multiply them. Multiply a to the power k1 into a to the power k2. A to the power k1 into a to the power k2 is equals to x1 into x2. That is a to the power k1 plus k2, properties of indices, x1 into x2. So we have a to the power k1 plus k2 is equals to x1 into x2. Okay. Clear with this? Right. So what we can say from here? A to the power k1 plus k2 is equals to x1 into x2. right? So if you transfer this to, this is the exponential format. The exponential format of powers. This is in terms of anti-log. Again, convert this to log. If you convert this to log, I'll do it over here. I don't want to scroll down, so I'll do it over here itself. So we have a to the power k1 plus k2 is equals to x1 into x1 into x2. Okay. So what I do from here, I have log x. If I take log, this is in terms of anti-log, convert this to log. So if you convert this to log, so this is your base. Okay, this is your base, a to the power, base to the power, this thing k1 plus k2, okay, equals x1 into x2. Convert this in terms of log again. So what we have? Log, now we have x1 into x2, right? x1 into x2. This will be a component of log. x1 into x2 will be a component of log. Base a. Base a is equals to what? k1 plus k2, right? k1 plus k2. Clear with this? k1 plus k2. So what is k1 k2? What is k1 k2? k1 k2 is log x1 base a and log x2 base a. So this is log x1 into x2 base a is basically log x1 base a plus log x2 base a. Clear with this? Is the proof clear? Okay. Write this down first. We move on to the next property. This is done. So this is the product rule. How to remember this? Simply remember in this manner. Log a into b is log a plus log b. Log a into b is log a plus log b. Okay. Also, I have seen some students creating mistake. What is that mistake? Never ever confuse with this thing that log x1 plus x2 is equals to log x1 x2. তাড়াহুড়োয় কিন্তু ভুল করে যাও, log x1 plus x2 is not log x1 into x2. Neither log x1 plus x2, neither log x1 plus x2 is equals to log x1 plus log x2. These are the two common mistakes I have found out. Okay, so be very careful with these mistakes. Log x1 plus x2 is not log x1 into x2. And log x1 plus x2 is neither do log x1 plus x2 is log x1 plus log x2. It is only by this product rule. So we have log a plus log b is equals to log ab. Remember like this, log a plus log b is equals to log ab. Next property, fourth one. Log x1 base a minus log x2 base a equals log x1 by x2 base a. Log x1 base a minus log x2 base a is equals to log x1 by x2 base a. Okay. How to prove this thing? Proof is once again quite simple. Similarly, in the same manner, you will try to prove this. This is your exercise. You can try to prove this. What you will do? In the previous case, we have considered the product. So in this case, we have division. So what we got? Same thing we are going to proceed. We have log x1 base a. Take this as k1. We have log x2 base a. Take this as k2. Okay. Now similarly, try to represent this in terms of x1 by x2. So in the previous case, what we have done? We have taken their product. So in this case, you have to take their division, x1 by x2. In the previous third case, we have considered this thing, a to the power k1 is equals to x1 and a to the power k2 is equals to x2. from which we have multiplied. Okay. So here what you're going to do? What you're going to do over here? You have to divide such that power becomes k1 minus k2 and this becomes x1 by x2. So you will get the result. Okay, so you all can try out this thing. Okay, try out on your own. So in the place of multiplication, you are going to divide. Clear? Next, fifth property. Fifth property. Okay, once again, how to remember this? How to remember this property? You simply remember like this: log a minus log b is log a by b. Difference is equals to division. Log a minus log b is equals to log a by b. Okay. Once again, common mistake. Common mistake I have seen. This is log a minus log b. This is not log a minus b is not log a by b. This is wrong. There is no such formula for log a minus b. Okay, no such property for log a minus b. Common mistake. I have seen lots of students do make. Fifth one. Fifth property. What is the fifth property? Very, very important. Fifth property. Log x to the base n, sorry, log x to the power n base a is equals to n log x base a. Whatever is the exponent over here, but the power of x comes down, comes to the left of n. So n log x base a. Okay. This is the property. How to remember this? Simply remember like this: whatever is the power, this will come down. Common mistake. Once again, what is the common mistake? Log x base a whole to the power n is not n log x base a. Common mistake. This is whole to the power n, but this is having only to the power n. X whole to the power n, x to the power n, not whole log x base a whole to the power n. Okay, so this is a common mistake students do make. Once again, I am telling. Now we prove this. How to prove this? Log x to the power n base a is equals to n log x base a. Prove. So you have log x to the power n. You have base a. Okay. Suppose you consider this to be k, suppose. Okay. So now convert this to anti-log. Convert this to anti-log. What is this? If you convert this to anti-log, base to the power k, right? Base to the power k is equal to the component of log, which is x to the power n. That's what we know. We are seeing from the very beginning. What we need to prove? You need to prove that n into log x base a. So what you are going to do? What you are going to do? Take the nth root. Take the nth root on both sides. কি বলছো? Common mistakes. আচ্ছা, common mistakes ওগুলো. Okay. Over here, the common mistake is log x base a whole to the power n is not equals to n log x base a. This is not true. Okay. Power is where? Power is with only x. Only x. Okay. Not with this whole log. Log x to the base a raised to the power n is not equals to n log x base to a. Right. This is the mistake. So we continue with the properties. The proof of this property. And the mistake also I have given, which is log x base a raised to the power n is not equals to n log x base a. This is the mistake. So log x to the power n base a is equals to k. This means a to the power k is equals to x to the power n. How we get this? Definition of log. Convert log to anti-log. So we have a to the power k is equals to x to the power n. Then what do you do? Take nth root on both sides. What is nth root? Whole to the power 1 by n. Take whole to the power 1 by n on both sides. Right? So we have k, a to the power k by n is equals to x. Because we are taking nth root, or simply take this whole to the power n on the left hand side. So this becomes by n, right? Taking nth root on both sides. Nth root. Clear? So we have a to the power k by n is equals to x. Right? Again, convert this to log. Convert this to log. This is anti-log. Convert this to log. So what we have? Log. So this is your component of log now. Right? Log x base a, because this is your base. Right? Jar power tar base. Shut out the base. So we have log x base a is equals to what we have? The power equals to the power mane k by n. Log x base a is equals to k by n. Simplify this. Cross multiply. So n log x base a is equals to k. And this is what we need to prove. N log x base a is equals to k. So k is x to the power n, log x to the power n base a, and which is the same as k is n log x to the power x base a is equals to k. Mane, this is k is equals to, if you compare with these two, so we have log x to the power n base a is equals to this thing, which is n log x base a. Obviously, same thing in this case also. In this case also, criterias are what? Criterias are x greater than 0, a greater than 0, a not equals to 1. A not equals to 1. Okay. Clear? Clear with this property, Bolo? Any questions in this property? Proof also I have shown. 2-3 more properties are there, and then we are going to start with the questions. Okay. Next property. So this is a very, very important property. This sixth property. Maybe where you will need these properties? You will need these properties when you study derivatives. Maybe some derivatives which are too lengthy, which can be like, let's say, very lengthy derivatives are there, right? You are asked to find out the dy by dx. A function is given, y is equals to something, a big value is given, and you are asked to find out dy by dx. What is dy by dx? So dy by dx, in order to find out the derivative, it's a very big expression. Normally, if you use the product rule, chain rule like that, this will consume a lot of time. So in that case, what we do? We introduce log. Log will simplify this, and then we differentiate with respect to x. Then we find dy dx. Next, sixth property. Sixth property. What is the sixth property? Log x. Now see the base over here. Base is what? Base is a to the power n. A to the power n. Log x base a to the power n is equals to 1 by n log x base a. 1 by n log x base a. Right? Log x base a to the power n is equals to 1 by n log x base a. This is also one important property. What we have? Log x. In the base we have a to the power n now. So 1 by n will come down and we have log x base a. Proof. What is the proof for this one? Once again, a very basic proof is there. Log x base a to the power n. Let's say this is equals to k1. Right? Use anti-log, convert this to anti-log. So we have a to the power n raised to the power k1 is equals to x. Right? Log x base a to the power n is equals to k1. That means a to the power n whole to the power k is equals to x. Anti-log, converting a log to anti-log. So this means now from here what we do? Take log on both sides. Take log on both sides or convert this to log. What we have is, sorry. What we can do from here is, let's take nk, write this as, convert this to log. Convert this to log means you have a to the power n into k1 is equals to x. Right. The next step was also valid. A to the power n into k1 is equals to x. Okay. If you convert this to log, so what we have? Log x base a is equals to n to the power k1, isn't it? Log x base a is equals to n into k1, sorry, n into k1. Right? So what we need to find? What is k1? K1 is what? K1 is cross multiply. What is k1? K1 is 1 by n into log x base a. Convert this to log basically. Anti-log, convert this to log. So we have k1. Now simplify. K1 is what? 1 by n into cross multiply. 1 by n into log x base a. So k1 is log x base a to the power n. K1 is also 1 by n log x base a. This implies log x base a to the power n is equals to 1 by n log x base a. 1 by n log x base, and this is what we need to prove. Till now, whatever you are doing, I think in 9th or 10th, up to 9th and 10th, you have seen common logarithms. We call this as common logarithms whose base is 10 basically. Okay, later on in higher classes, you will deal with natural logarithms in derivatives and all. So you will deal with natural logarithms. So in spite if it is not mentioned that base is 10, so don't take the base to be 10. Take the base to be e. Okay, what is the meaning of that? Write down, note. Before we continue the properties, write down, note. First is common logarithm. What is the meaning of common logarithm? Logarithm with base 10. Logarithm with base 10 is known as common logarithm. Logarithm with base 10 is known as common logarithm. Right? And second one is your natural logarithm, a more fundamental logarithm, which you have applications in calculus as well. If it is not mentioned, then you are going to consider the logarithm to be natural log. Natural log means ln x. We deal with ln x. So natural logarithm is basically the logarithm with base e. Logarithm with base e is known as natural logarithm. Is known as natural logarithm. So logarithm with base e is known as natural logarithm. So now natural logarithm, first of all, base e is what? What is e? E is the Euler's number. What is the value of e? E is equals to 2.718. Remember this value, approximate value. This is actually 2.718 and so on. But approximate value is E is 2.718. Meaning E is any number which is lying between 2 and 3. Okay, E is any number which is lying between 2 and 3. And what is this E? E is an irrational number. E is an irrational number. Just like pi, you have E to be an irrational number. Okay, E is an irrational number. Okay. Also note down this point. If nothing is mentioned about the base, if nothing is mentioned about the base, consider it to be base E. Consider it to be base E. Okay. Nothing is mentioned about base, then consider this to be base E. And you can add one more point. Natural logarithm is denoted by ln x. This is common logarithm, which is log base 10. This is log anything log x base 10. And this is natural logarithm, which is given by either ln x, okay, or you can give it in this manner, log x. This is also accepted. Or you can give it in this manner, log x base e. This is also accepted. Value of a base is equals to e. Either you write this as ln x. In many books you will find this to be ln x, which means natural logarithm. Or you write this as log x. Sometimes we call this ln x to be ln x. Ln x, natural, and logarithm. So ln x or log x or ln x, or we have log x, or you write this as log x base e. Okay. So if nothing is mentioned about this base, then consider this to be base e. Consider the base to be base e. In short, you can write this as log x base e is equals to ln x. This is the thing. Overall, what we have discussed. Okay. This is the concept. Very, very important. You need to know the difference between the common logarithm and natural logarithm. Okay. And one more thing, I hope you remember this thing. I told about this E actually. I hope you remember this thing, right? That E can be obtained by computing this sequence actually. Sorry, series. Computing this series, you can obtain the value of E, the Euler's number actually. Okay, this particular series up to infinity. This particular series was there. I told you that this particular series, if you evaluate this series, you will get the approximate value of E. We don't know the exact value of E. I told you that E is an irrational number. In fact, it is non-terminating and non-repeating number. Just like pi, we have E actually. And this is the approximate value of E, you must remember. I have told this previously also. Okay, just a fact. In fact, I'm telling you this thing. This is Euler's series actually, from which Euler gave this thing. Okay, which said this is exactly how we calculate the approximate value of E actually by calculating the value of this particular series. Okay, in further detail of study of this particular series, we will do under series section. In fact, special series are there. Well, we studied a lot of series, different types of series. There we are going to discuss this particular thing. So we have done product rule, we have done difference rule. What else is there? One more property we have there, very, very important, which is known as the base change formula. How to change base and write it. What is the base change formula? Chalo, what is log, the base change formula? Base change formula of log. This is number 7, I think. log x base a is there. Okay, clear? So log x base a is there. I want to change the base. I want to change the base. How will I change the base? You have log x base a and I will change the base. This is known as base change formula. How will I change? So first what I'll do is I change this manner, that this is log x base a. So first write down log x base e. Okay, log x base e divided by log e base e, log a base e. Okay, with new base and old base. This is your old base. This is your old base. Okay, clear? This is your old base and this is your new base, which is e. This is new base. So when you are asked to transform log x base a, so you will simply write this as log x base e upon log a base e. This is the property. Okay. Okay, fine. So what is the meaning of this thing? You remember like this manner. You have to remember this thing in this manner, that whatever was the old base, that will be now the component of log this thing. Log x base e. E is what? E is nothing but the new base. E is nothing but the new base. Okay. So log x base e divided by log a base e. E is the new base. E is the new base. A is the old base. Okay. So like suppose let's say the base change formula. Let's say one example only. Log. Let's say log x base 7. What is log x base 7? You're asked to convert this, change the base of this, change the base. You change the base to a base 10 or base c, whatever it is. Let's change this to base 10. So what you will do in that case? Write this as log x. What is new base? What is new base? New base is 10 because you are changing to log 10, base 10, divided by log old base 7 base 10. Okay. So you remember in this manner that we have log x upon old base, log x to the log x to the base of old base is equals to log x base new base divided by log a. What is log a? Log a old base with the base new base. All the new base will come here, log x will go here, old base will come here. This is known as the base change formula. This is known as the base change formula. This is not a formula. This is a method which I have discussed to change the base change formula. Further, we can break this numerator. Similarly, break this numerator, denominator. You will get this result log x base a. By properties of log, simply break this numerator, denominator. You will get this back log x base a only. Okay, so we need not need the proof of this thing. This is the base change formula. This is a method of changing the base. Whenever you're asked to change the base, you can use this particular method. Okay. take this down. This method is very important. Okay. It is not compulsory that every time you will get E only. Just a new base will be there. If you are asked to change in terms of a new base will come and log x, and this thing will be over here. Okay. You can also, if you don't understand this thing, you can write it in this format, that this thing is basically you can write this same property in this manner. Let's say in this manner, log m base a. Suppose you have log m base a. This is log m base b divided by log a base b. Log m base b divided by log a base b. B is what? B is the new base. B stands for the new base. Okay, same formula, same property. B stands for the new base, and A stands for, what is A? What is A? A stands for the old base. What is M? M is the component of log. This is the part of this log. Right? Clear? Okay. So from here only, you can determine more results, which you can gradually just see from here itself, but you don't need, like, further expansions can be there. You can cross multiply, see what are the various results from here. Not needed. Like if you just see, you will get one common result from here. If you just see from here, if you just cross multiply these two, you will find in various books that this particular common result is given, that if you just cross multiply this, then you will get log m base a into log a base b is basically log m base b. Logic is the same. You just only need to remember this thing. Remaining you can simply cross multiply and find out. So many things you don't require, only the main properties important. The base change formula. This is very important. This is the base change formula. Either you remember the previous method, the previous way, how we have done this. Mane log old base mane log x base is old base. So this is log x base new base divided by log old base to the base new base. Or you remember in this manner. This thing, log m base a is equals to log m base b divided by log a base b. B is the new base, a is the old base. And if you cross multiply, you will get this. If you cross multiply, you will get this. Also, from here also, we can determine one more thing, that if suppose over here in this expression, suppose if you replace b by m, suppose. This is one more observation. You don't need to remember. If you want to remember, you can. If you replace b by m, suppose, replace b by m, okay, just simply replace this b by m, all these b by m. So what we have, okay, or in this main equation, let's see in this main equation. In this main equation, replace b by m, okay, this b by m, this b by m. So what we have, so we have log m base a, log m base a is equals to log m base m divided by log a base m, right? Clear? What is the value of log m base m? Just now you have seen log a base a. This is 1. This is 1. So cross multiply. So you have one more result. You can just simply gradually generate from here, that is basically log m base a into log a base m is equals to 1, because this is 1. Just now you have seen log a base a is equals to 1. Okay, so this is also one result. If you want to remember, you can, but so many things are not needed. Just basic properties of log will work out. Okay, but the base change formula is important. You need to remember this base change formula. So log m base a into log a base m is equals to 1. How do you prove this? Simply replace b by m in this expression, in the base change formula. You get this result. So likewise, many results can be derived. Okay, so one by one we have covered almost all of things. Overall, we have covered all of these only. Particular case, there can be many such particular case. You have almost done all of these. All the things you have done. Some particular cases are there. I just told you that so many things are not required to remember. Like over here, you have a particular case for this one. Let me see this one. Where is that? Combining this sixth property and this fifth property. Okay, I'll combine fifth property and sixth property. You have a combined property. You have a combined property, but this is also once again not required. Special case, particular case, combining fifth property and sixth property. You have log n to the power, let's say n to the power p, a to the power q. If you have this format, base is also in powers. This component of log is also in power. So this is p by q. P by q will come here, and this becomes log n base a. P by q will come here, and this becomes log n base a. This is nothing but the combination of fifth property and sixth property. The composition basically. They have combined these two, so you have this particular property. If you want to remember, you can, but so much is not needed. You can gradually generate all of these in the exam. If you want to, you can. Okay? If you want to, you can remember this. If you don't remember this, no problem. Just simply remember that this is the composition of the fifth and the sixth property. You see, they have combined the sixth and fifth property. We'll find many such properties in the books. This one, fifth one is what? This thing, log x to the power n base a is n log x base a. And sixth one is basically log x base a to the power n is basically 1 by n log x base a. Okay, so gradually we have just simply combined these two. You have now simply take power over here, x to the power n. So this will become simply 1 p by q will be there. There I have considered x to the power p, and here I have considered x to the power a to the power q basically. You have p by q log n base a basically, right? So this one, combination of fifth and the sixth property, you can write it down. So many things are there. Okay, so all these are not so important. Likewise, you can create many expansions, many extensions of formulas, many extensions and many representations of formula will be there, but first 2-3 properties are very, very important. First 2-3 properties are very, very important. Okay, I hope this thing is clear now. Right? Bolo. Overall, we have covered almost all the properties. 6-7 laws are there which are very important. We have also covered this, and some extension, extra extension parts are there which we have covered. Now so much of things are not required. Now we can start solving the questions, right? Also, now if you just see, with the help of the properties what we have done, can we now solve this thing? Log 1000 base 0.01. Can we now solve this with the help of the properties which we have covered? Suppose if I consider this log 1000 base is what? 0.01. So let us write this as 1 upon 100, right? 1 upon 100. And let's write this 1000 as 10 cube. What is 10 cube? 10 cube is 1000. So let's write this as 10 cube. And this 1 upon 100, 1 upon 100, this is 10 cube, and 1 upon 100 is what? 1 upon 100 is 10 to the power minus 2. 10 to the power minus 2, right? 10 to the power minus 2, and here we have the component to be 10 to the power 3. Suppose this is equals to k1, this is equals to k1. Suppose we are asked to solve this. What is the value of k1? This is your question. What is the value of k1? Find the value of this thing. Find the value of this thing. This can be a question. Find the value of log 1000 base 0.01. Okay, so I am converting in this manner. Then what do you do in this case? What we have? If we have powers over here as well as powers over here, right? So this what? First of all, this power comes down, right? First of all, this power will come down. So we have 3, right? 3 log 10 base 10 to the power minus 2 is equals to k1. First of all, this thing you have to remember that whatever is the component to the power is there, this will come down. Whole to the power hole kintu namto na componenter power hole, then only this will come down. If this is whole to the power this, then this will not come down. So this is 3 log 10 base 10 to the power minus 2, and we have log 10 over here. And this is equals to k1. Now simplify this. What is this thing? 3 log 10 base 10 to the power minus 2. How do we simplify this? Log 10 base to the 10 to the power minus 2. How do we simplify this? Use the property. Which property? What we used to do in case of 10 to the power minus 2. Go back to the properties. You have this property. This thing. Log x base a to the power n is 1 by n log x base a. Log x base a to the power n is basically 1 by n log x base a. So 1 by n mane n comes down. What is n? What is n in this case? N is minus 2. Minus 2 comes down. So this is minus 3 by 2 log 10 base 10 is equals to k1. What is log 10 base 10? This is 1. So k1 is minus 3 by 2. Either you solve in this process or you solve the previous logic. How we have solved this at the very beginning of the class, we have solved this with the help of very basic definitions. This one log 1000 to the base 0.001. By basic definition of log, we have solved. See, x is minus 3 by 2. X is minus 3 by 2. Either you solve in this manner or you solve in this manner. By properties of log, use properties of log to solve this thing. Right? Clear with this? Next property. Koto, this is property number. Next property. What is this next property? Koto number? Koto eta 7, 8. Eighth property. Eighth one. A to the power log n base a is equals to n, where a is greater than 0, right? A not equals to 1. What else? What is n? N is a positive rational number. Any positive rational number. Okay? N is a positive rational number. A to the power log n base a is equals to n, where a is greater than 0. A not equals to 1. N is what? N is a positive rational number. N is a positive rational number. So this is what? You convert this. Convert this. What we have? If you have a raised to the power log n and base is also a, then this is equals to n. Okay. This is the conversion of log basically. You can also see this with the help of taking log both sides. Take log both sides. Suppose over here you take log both sides. If you take log both sides, then this power will come down. This power will come down. So you will have log n base a into log a equals to log n. Okay, that's how you are simplifying basically. Or if you don't want to do so, just simply what can we do? Just simply then transfer this thing, transfer this log n base a, consider this to be some value, and try to simplify this thing. Okay, this is the base. Converting this to anti-log basically, just a number. N can be written as a to the power. Any number can be written as a to the power n, a to the power log n base a. And similarly, suppose you have this thing that you have. Similarly, suppose if I consider, let's say for example, let's say you have this as e to the power x. Suppose you have e to the power x is equals to k. E to the power x is equals to k. Okay. If you take log both sides, then what will happen? If you take log both sides, then this will become x log e is equals to log k. What is log e? Log e is 1. Log e base e, that is 1. Right? I told you what is the base. Base is always considered to be e. So we have x is equals to log k. So this is the conversion formula. All of you know this thing. I have discussed this quite a few times in calculus as well. We have used this property basically. Converting to log, converting to e. Exponential format, log format. If suppose if this format is given in exponential format is given, then you can convert this to log. Or if log format is given, similarly, if suppose log is given, log of k is equals to m suppose, then k is equals to base is always e, so k is basically e to the power m. Okay, this is the main thing, and we have discussed this quite a few times. All of you know this thing, how we have applied this property in there itself. The proof is not so important. You can see the proof of this particular thing, which is a very easy proof actually, the formal proof. I'm talking about the formal proof. If you want to see the formal proof of this thing, just simply take log on both sides. Over here in this particular expression, if you take log on both sides, suppose for instance, you're taking log on both sides, so this becomes log a to the power log n base a, and this becomes log n. Okay, we are simply taking log on both sides. In fact, we take log on both sides with base a. Okay, with base a, we are taking log on both sides with base a. So by the properties, the previous properties of log, we know that this particular thing will come down over here in the powers. A to the power log n base a will come down, so this will become log n base a, okay, into log a, okay, log a base a, and this turns out to be, this remains the same, log n base a. Now left hand side you can see that this becomes 1, log a base a, this will become 1 by the property. So here we have log n base a is equals to log n base a. So you can see that this relation is true. This relation is equivalent. This is holding actually. So if this relation holds, then this relation also holds actually. We have simplified this relation only to get that, to get this relation actually. So clearly this relation holds. So this is also holding. So obviously this is a true relation. This relation is a valid relation. This is a very simple proof. So you can just simply take log on both sides and prove. Like the proof from now onwards, from 8th or 9th property onwards, basically you can see that these are just the applications of the previous properties what we have learned. Okay. One more property can be there. I think, I don't know if I've saved this or not, but you must know actually this property. In case if you have done, it's fine. But in case if we haven't done, one more property is there, that if we have log a to the power log, let's say c base b, suppose this and this expression c to the power log a base b, these two expressions are the same. If you interchange also, likewise how I have interchanged over here, the base being the same over here, I have only simply interchanged these components. If you interchange also, then there will be no difference. Again, a very simple proof. What we have to do, just in the similar manner, I told you, you just simply take log on both sides, you will see the expression getting generated over here. Some relations you will get, from there we can conclude that this is true actually. You simply take log on both sides. Suppose if I take log on both sides, so this will become log a to the power log c base b, and right hand side we have log c to the power log a base b. Okay, we are simply taking log on both sides. Again, in fact, we take log on both sides with base b. Since here we have the base as b, let's take log common with base b. Log on both sides with base b. Okay, so what we're getting from here is, if you simplify this thing using the properties of logarithm, here we have log c base b comes down. So this will become log c base b, okay, into
log a base b. Okay, and here we have log a base b comes down. We have log c base b. So here we can see that these two are equivalent. You can see that log c base b, and here we have log c base b. Okay, and here we have log a base b, and here we have log a base b. So these two both sides are equivalent. So clearly this particular interchange of these components are allowed, and this property is true. If this is true, this relation is true. So clearly this relation is also true. And clearly if this is true, so this is also true. If this is holding, this is also, the main relation is also holding. Okay, so these are your more or less properties you have in your log. Overall, we have completed all of the properties.
Okay, so let's move on to the main thing, questions of logarithm. What we do in this case, prove that if log a plus b by 2 is equals to half log a plus log b, then a is equals to b. That is what we need to prove. So what we do is we start with log a plus b by 2. Okay, write this as log ab. That is fine, log ab. Okay, so we have log a plus b by 2 is equals to what we have, ab raised to the power 1 by 2. Log ab. This power will go over here. So we have log ab raised to the power 1 by 2. Now can we cancel out log from both sides? Can we write this as a plus b by 2? Nothing is mentioned, so base is e. Can we write this as e to the power log ab whole to the power 1 by 2? E to the power log ab base e. What is this? ab raised to the power 1 by 2. Right? So basically log cancel us from both sides, nothing else. But be very careful with the base. So ab by 2 is equals to ab raised to the power 1 by 2. Everything what you need to do is you need to remember the properties and apply the same in the question. Whether you remember the proof or not, you need to remember the properties and apply them in the questions. So a plus b by 2 is equals to ab, this is basically root ab. That means simplify this. What is ab by 2 is equals to ab whole to the power half. Simplify this. What we have, a plus b is equals to 2 root ab, which means a plus b minus 2 root ab is equals to 0. Right? Clear with this? This means, what is the meaning of this thing? Root a minus root b whole square. Right? Root a minus root b, isn't it? A plus b minus 2 root ab, root a minus root b whole square. Root a whole square mane a square. A basically, root a whole square is basically a. Minus 2 into root a into root b, that is root ab, plus b square. What is b? B is root b. Root b whole square mane b. So root a minus root b whole square is equals to 0. What is the meaning of this? A is equals to b. Simplify this. What is this? Root a is equals to root b, mane a is equals to b. Hence proved a is equals to b. That is what we need to prove. A is equals to b. Right? Okay. Quite basic question we have started off with. Okay. Take this done quickly. Next question. Directly we move on to this question. Read the question carefully. I said that I'll just simply do two or three standard most questions, which are three, four standard most questions we are going to do, which are helpful for your exams. And last day I told one thing. Nowadays IIT-JEE questions are being repeated in JEE mains as well. Previous IIT-JEE questions, JEE advanced questions are being repeated in JEE mains. And I told you that someday you might get some questions from previous year IIT-JEE paper, JEE advanced paper I'm saying. So similarly, this is a JEE advanced question which was asked in JEE mains this year. I think in the March or in the March or most probably in the April attempt, most probably. Anyways, so find the value of this entire expression. Anyway, so let's solve this. How to solve this thing? You have a huge entire expression like this, And how do we simplify this? Obviously, we have to simplify this expression in order to solve this question. In order to solve this question, you have to simplify this expression, right? Okay. So how we are going to simplify this thing? This is our main target. And remember, if I tell you, whenever you have this particular expression of this format, means something root, again you have root, again you have root, and so on, this continues. Means something plus, let's say, x1 plus root, means root over of x1 plus root over of x2 plus root over of x3, like this, many terms are going, or in multiplication format they are going, right? Then remember, the question is very, very easy. Remember, the question is very, very easy. In order to simplify this thing, how will you simplify? So this concept will be helpful in your derivative as well. Now I am showing this thing. This concept will be helpful in your derivative as well. Okay, in derivative you might get certain functions of this format. You have x plus root x plus root x plus root x and so on, like this. Okay, and you're asked to find out the dy by dx. This concept is helpful over there also. Understand what is this thing? Root 4 minus 1 by 3 root 2 square root of 4 minus 1 by 3 root 2 square root of 4 minus 1 by 3 root 2 and so on. This is given and product continues. Okay. So suppose if I consider this is y is equals to this thing. Y is equals to root over of this, root and so on, continues. So can I say, observe from here, if you close this part, let me explain like this. If you close this part, take it out, a part take it out. So you have the remaining 4 minus 3 by root 2, again 4 minus 3 by root 2, again 4 minus 3 root 2. A part take it out. This is remaining. Once again, this will continue 4 minus 3 by root 2. Sorry, 4 minus 1 by 3 root 2 into 4 minus 1 by square root into 4 minus 1 by root 1 by 3 root 2 and so on. This will continue. Again, if you close this part, this will again continue. Right? This keeps on going on. Can I say this is nothing but square root of 4 minus 1 by 3 root 2 into y? Y is basically this thing. So if you close this part, this is also your y. The remaining part is also y. If you close this part, remaining part is also y. You close this part, remaining part is also y. Y continues. Right? Is this part clear? Bolo. Is this part clear? So 4 minus 3 by root 2 into y. Next, what will I do? Square both sides. Simplify. Square both sides. So we have y square is equals to 4 minus 1 by 3 root 2 into y. Okay, we square both sides, nothing else. Now solve this quadratic. This is just solve this. It's a quadratic. Then from there we are going to take the log afterwards, because we need to simplify this first, right? Simplify, find the value, then we are going to take the log. Okay, so y square is equals to 4 minus 3 root 2 into y. So this is y square plus 3 by root 2, 1 upon 3 root 2 y minus 4 is equals to 0. Now what will you do? Square, just simply solve this quadratic, basic quadratics. Simply solve this or use the Siddharth Acharya rule. Multiply with the 3 root 2. So we have 3 root 2 y square plus y minus 4 into 3 root 2, which is 12 root 2 is equals to 0. Now solve this. Use the Siddharth Acharya rule. So we have y is equals to minus 1 plus minus square root of b square minus 4ac. What is b square? B square 1 minus 4ac. 4 into root 2, that is 2. Sign will be plus. Minus is there, so sign will be plus. So 4 into a into c. 4 into 3 into 12 into 2, that is basically 12, that is 288. 288 divided by 2ab, 6 root 2. So y is basically minus 1 plus minus square root of 288 plus 1, that is 289 divided by 6 root 2. What is this? 2 square root of 289. 289, 17, na? 17. So y is basically minus 1 plus minus 17 by 6 root 2. Right? So what is y? Y is 17 minus 1 by 6 root 2. 17 minus 1, 16 by 6 root 2. Right? 16 by 6 root 2. That is basically 8 by 3 root 2. Or y is what? Y is basically minus 1 minus 17, minus 18 by 6 root 2. Right? Or y is equals to 18 minus 18 by 3 root 2. ঠিক আছে দেখো একবার, right? 18 by 6 root 2, 3 root 2 na, 6 root 2. 6 root 2. মানে basically 6 দিয়ে কাটলে, that is basically minus 3 by root 2. Now, should I consider the minus values? Should I consider the negative values? Should I consider these values? Obviously not. Why should we just neglect these values? Because what is this? This is log of this thing. Log, whatever it is, domain is defined for positive real numbers. Positive real numbers. Log cannot be negative. So, what is the value of y? Y will be only 8 by 3 root 2. Y will be only 8 by 3 root 2. So, value of this thing is what? 8 by 3 root 2. Now simplify. So 6 plus log 3, you have 6 plus, therefore 6 plus log, this entire thing, entire product is now what? Is basically, this product was 1 by 3 root 2, right? 1 by 3 root 2. Base is 3 by 2. So this is 1 by 3 root 2 into 8 by 3 root 2. 8 by 3 root 2. Now simplify. This is what? This is 2 into 2, 4. This will become 2 by 3, right? 2 by 3. And this becomes 2 by 3. That is basically, I think this is, cancel out 2 into 2 ashbe. This is root 2 into root 2. That's basically 2. 2 and this will cancel out with 4. So that is basically, this thing will become 6 plus log base is 3 by 2. So this thing will become 2 by 3 whole square, isn't it? This will become 2 by 3 whole square. Log 2 by 3 whole square base 3 by 2. Okay. What is the value of this thing? Simplify this. What is this? Log 3 by 2 and 2 by 3. What is the value of this thing? Use the property 6 plus, this is what? 2 will come down. 2 will come down, isn't it? 2 will come down, and here we have 3 by 2. 3 by 2 is obviously greater than 1. Obviously, this is true. 3 by 2 is there. What is the value of this? 2 will come here, and here we have log 2 by 3 base 3 by 2. What is the value of this thing? Tell me. Log 2 by 3 base 3 by 2. কত আসছে? Use the properties of log. Yes. So we have 6 plus, plus এটা 1 না, minus 1 আসবে. This is minus 1. minus 1 আসবে. minus 1 তো না, সংখ্যাদীপ minus 1, হ্যাঁ minus 1. This is minus 1. So this is 6 minus 2. 4 আসছে? Yes, correct. This was given in integer type, numerical answer base. So a very nice question. In fact, this was asked in IIT-JEE 2012. Okay. Chalo, next question.
Okay, students, so this is your next question, and this is from ISI 2009. We have to find the number of solutions of theta in this interval 0 to 2 pi. We have this entire complicated equation given in terms of log, then tan theta is there, everything. So how do we solve this question? This is equals to -1. In fact, we have to solve this question. Basically, we have to solve for theta. That's all. Okay. So definitely if log is involved, so there must be some properties and use of some properties, and definitely we have to simplify this in order to solve for theta. Let's solve this. Here we have log tan theta base √3. Okay. Let's simplify this inside portion of this root actually. So here we have log tan theta base √3. Okay. This is log 3 base tan theta, and here we have 3√3 base √3. Let's do one thing. Let's bring the base as the same. Okay, let's bring the base same. Means we use the base change formula. Let us try to bring the common base over here. We have the base as √3. Here we have √3. Let's try to bring the base in terms of √3 using the base change formula. I hope you're getting what I'm trying to say. Okay, so here we have log 3 base tan theta. To bring this as the √3, we use the base change formula. That is what? That is actually this will become. This 3 is nothing but √3 whole square. Isn't it? This is √3 whole square. So in fact, if we have log √3, now what we're going to do, first of all, here we're going to have the, let me write this as √3 whole square. Now this will be replaced by the new base. And then old base will come as a component over here. And the new base will come as a base over here. Old base comes over here. Again, power log √3 base whole to the power 2. The component's power is 2. Again, what you can do is to simplify this further, you can bring this down. This is 2 times log √3 base 3. So clearly this will become 1. So only 2 will be remaining. Now let's simplify this part also. Log 3 √3 base √3. What we can do from here? Here we have log. First of all, let's simplify this. Here we have log 3 √3. We can write this as log 3 base √3 plus log √3 base √3. Log AB is what? Log A plus log B. This part is becoming what? 1. Okay. This 3 is nothing but √3 whole square. Again. So this 2 will come down once again. 2 comes down over here. So this becomes log √3 base √3. This will again become 1. So 2 into 1 plus 1. So that's 2 plus 1, 3. Okay, so our inside portion is now simplified to log of tan theta √3 times. This becomes 2. This is 2 upon log tan theta base √3 plus 2 plus 1, 3 over here. This is our simplified version actually. Obviously, square root was also there. Do not miss out the square root. Square root was there. Do not miss out the square root. Okay. And since this was an equation, right hand side we had -1. This was -1. Now we have to further simplify this. We have to solve for theta. So here one thing we can see common is this term and this term. So let's take some substitution. Later on we can replace this value. So let's take log tan theta base √3 as, you may take anything. Let's say, let's take x. This is to be x. We're going to simplify this thing. Okay. So if you replace this x over here, so this becomes x times 2 upon x plus 3. Okay, a simple looking expression like you can see from here. This is a simple looking expression over here. We have taken this thing just to simplify this. Okay, this, if you keep on, you can keep this also, but this looks actually sometimes you may get scared of these type of huge expressions. So it's better you may take certain substitution if you have this term. and later on we can replace the value of x. So let's solve this thing. So here we have x times square root 2 upon x plus 3. If you take this x over here on the right hand side, so we have 2 upon x plus 3 is equals to minus 1 by x. Now see from here, we have square root on the left hand side. Right hand side we have minus 1 by x. Okay. Now this expression is true when? This expression is true only if x is negative, because when x is negative, then only minus minus cancels out. Here we have 1 by x, which is a positive quantity. Otherwise, square root of 2 by x, this particular thing will never give you negative quantity. Square root of anything cannot give you a negative quantity. So clearly this will give you a positive quantity only if x is negative. Then only now this particular minus minus cancels out, and then you will have this particular thing as positive quantity. Okay, so x must be negative in this case. Be very careful. X must be negative in this case. So now if you square both sides, so then we'll have on the right hand side, on the left hand side, we have 2 upon x plus 3 is equals to 1 by x square. Where x is negative, be careful. Positive values are not accepted over here. Okay, so let's simplify this thing. So this will turn out to be a cubic equation, I think. So let's simplify this thing. So here we have if you simplify, cross multiply, so here we have x times 3x square plus 2x minus 1 is equals to 0. So from here x is negative. Be very careful. X cannot be positive. X has to be negative. So only solution from here will be, if you factorize this thing, what you will get? If you factorize this thing, you will get 3x minus 1 into x plus 1 is equals to 0. Okay, so clearly from here you have to accept only the value x is equals to minus 1, because x cannot be positive. So only x is equals to minus 1 is possible. So from here we have log tan theta base root 3 is equals to minus 1 from here. Now let's simplify this thing. So this will become log of tan theta base root 3, and here we have minus 1. So this turns out to be tan theta. If you remove this log, so this will become what? Tan theta will be minus 1 by root 3. Sorry, 1 by root 3. This will become 1 by root 3 by the properties of log. This will become 1 by root 3. So theta from here, what will be theta from here? Theta will be pi by 6. And what else? Pi plus pi by 6, third quadrant. Pi by 6 is one of the values where tan theta is actually means this equation is satisfied. Theta's values are satisfied. We have to be very careful of this thing here. They have mentioned 0 to 2 pi as the restriction. So here we have theta is pi by 6 and pi plus pi by 6, third quadrant. That is 7 pi by 6. So we have two solutions, that is pi by 6 and 7 pi by 6. So there are two solutions for theta. So this is a very nice question compared to the other questions. You won't find this particular types of questions, rarely you will find, but it's a very nice question asked in ISI 2009.
If log x by a square plus ab plus b square is equals to log y by b square plus bc plus c square is equals to log z by c square plus ca plus a square, then find the value of x to the power a minus b, y to the power b minus c, z to the power c minus a. Okay, how will you solve this? Try to solve this. Try to solve this first. You have log x, log y. Eliminate the log. Find out what is x, y, and z, and put the values and find out. But to eliminate this value, you have to do some sort of logic you have to apply. What will you do in this case? Try out. We have log x divided by a square plus ab plus b square. You're asked to find out this thing, x to the power a minus b, y to the power b minus c, and z to the power c minus a. So overall, you have to eliminate this log x, log y, and log z in order to find this. I think this is a question of your 10 plus 2, probably, most probably. 10 plus 2 a question, I think. Small trick is there. If you understand the trick, then this question will be solved easily. Equate all to a constant. Okay. If you equate all to a constant, obviously you will, but how to simplify this thing and bring in terms of find out what is x to the power a minus b. So one thing I can see from here, if you see, carefully observe, what I do is, if you equate it to a constant is fine. Exponent concept. Most constant will cancel out, that is fine. But the thing is, although this is a cyclic coefficient, obviously, it's a concept of cyclic coefficient. But cyclic coefficient is in case of coefficient. This is not coefficient. They are not asking for the cyclic money. Nothing we have to deal with the coefficients. We have to bring this in the form of x to the power a minus b. So one idea will come to your mind that if I take a minus b log x and divide by a minus b, a square plus ab plus b square. Same thing goes here. Similar concept, b minus c. Why will I take this? I will take this because if I take this over here, this becomes log x to the power b minus c. So x to the power b minus c will come. X and y chilo. Y, sorry. I'll take y. So y to the power b minus c will come. So over here we have b square plus bc plus c square is equals to, this is c minus a, similarly log z upon c minus a into c square plus ca plus a square. This thing will come. So now what I have, denominator is what? A minus b into a square plus ab plus b square. What is that? A cube minus b cube, right? Numerator is log x to the power a minus b divided by a cube minus b cube equals log y to the power b minus c divided by b cube minus c cube equals this thing, log z to the power c minus a divided by c cube minus a cube, right? Clear? Simplification, basic simplification, nothing else. So what we have from here, a cube minus b cube minus c cube minus a cube. Next, what I do? One thing we can do is put a constant near. Let us take this to be some constant k. Correct. Ekdom. Take this to be constant k, separate them, add them. You will get the result. And log x to the power a minus b divided by a cube minus b cube is equals to k. Okay, similarly this is equals to k, this is equals to k. Separate them and add them. Log y to the power b minus c is equals to divided by a cube minus b cube is equals to k, and log z to the power c minus a divided by c cube minus a cube is equals to k. Next, what? Cross multiply, add them. Cross multiply and add them. Log x to the power a minus b is equals to k into a cube minus b cube. Log y to the power b minus c is equals to k into b cube minus c cube, or log z to the power c minus a is equals to k into c cube minus a cube. Now add 1, 2 and 3. This is log x to the power a minus b plus log y to the power b minus c plus log z to the power c minus a is equals to k into a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Now cancel out. B cube cancel out. C cube cancel out. A cube and A cube also gets cancel out. Left hand side is log A plus log B plus log C, mane log ABC, x to the power A minus B into y to the power B minus C into Z to the power C minus A, right? Log A plus log B plus log C is equals to, this thing is 0. This is x to the power A minus B, y to the power B minus C into Z to the power C minus A. This is log mane e to the power 0. This is 1. This sum is left. This I'll give you a hint. You all will try out this particular question. I'll just give you a hint for this. What is the hint? Hint is nothing but simply solve this equation. 3 to the power x is equals to 4 to the power x minus 1. Solve this. Solve this by taking what we have. We have all these are having options are what? X cannot be equals to this thing. X cannot be equals to this thing. No other option. Take log on both sides and solve. Nothing else. Nothing else can be done. Take log on both sides and solve. Okay. Take log on both sides. Take log on both sides and solve for x. Solve for x and see x cannot be equals to which of these value. Which of these value. Okay. Which of these value or values. Multiple answer can be correct. So solve this. Okay. More questions are there regarding functions. Regarding logarithmic functions, let me say one thing. We have discussed this in the class of functions, mainly in the class of functions, right?